semester and 8th semester. So everything regarding your project, you should consult with me. But meantime, regarding your this work which you want to do in your 2 years your project work, that you have to discuss with your supervisors. But before assigning the supervisors, you have to give me your name list. Your Abhijit has prepared one Google form where you can one Excel form where you can write your groups. There 3 to 4 members. You can make one group. Okay. So one sample is already done. So Abhijit, you share with your friends, let them fill up the group members and submit to me if possible by today. Otherwise, or not before Friday, you submit to me so that by Monday, the next Monday, I will assign the supervisors and will give it back to you so that you can start your work. Okay. And regarding your project title, it is up to you. You can choose your own project title, or otherwise, you can discuss with your guide and you can finalize one title. Okay, this title which you have chosen now, that will be your final project title until your 8th semester. Okay. Meantime, if you want to change anything, you have to change within this semester. This semester means before your end semester, because midterm, after midterm, 1 week after midterm, we will have your first project seminar presentation. There we will discuss about your title, what you have chosen, then what algorithm you are going to use, and what kind of work you are going to do. That everything we will be discussing in your first project presentation seminar. And by end term, we will be having another project seminar there. You have to start working. Okay, you have to start working your project, and there at least some implementation or part of your implementation you have to show in the project presentation. Okay, so initially your first step is to make groups. To make groups, it can be 3 to 4 member groups, and uh, the names you submitted before Friday. So we can process with other necessary things once you submit your project. Once you submit your group names to me. Okay, that is the first thing. And tomorrow we won't be having your class because 4 to 5 I think I have my class tomorrow. So since I have an important work tomorrow, so I'm just going to conduct the class today. And from Thursday we will start our offline class at college. Okay. So now we will start. Let me share the screen. So last class we have seen about some calculations on computing error measures, forecasting, regression, moving average, mean square error, mean absolute distance, all those things, and I have given you assignment also. I think very few of you have submitted the assignment, so you try to submit as soon as possible, because at the end of your this semester, all this assignment marks, class attendance will be given as an internal. Okay, so this will be counted as your internal marks. So try to submit your assignments for those who have not yet submitted, and try to attend the classes also. If I ask you online or offline, whatever the class it is, you try to attend the classes. So all this attendance, your class assignments will be counted as your internals. Okay. So now our next topic is uh, this has been done. So measuring predictive performance. So here, normally the performance will be measured in terms of mean error, error rates, or distance, whatever we have discussed earlier. Okay, so all those things are measures for evaluating the performance. I already told you, right? Significance is also one of the measures for calculating the performance, and your mean absolute error, mean absolute distance, mean square error, then this moving average, then error rates. So complexity analysis, all these are some measures for evaluating your performance. So our objective for a correct prediction is our objective for predicting the performance or for calculating the performance is to get an accurate prediction. Okay, an accurate prediction. So that's why we have performed all this performance analysis and all. So now one of the technique which we normally use for predicting the performance is random training and testing. So randomly from our data set. So all these things what I'm telling you now will be useful for your project work also. You will be performing certain training and testing because for every data you use for your implementation, that data will be trained and tested, right? So this random training and testing is also one method where you perform the prediction performance analysis. So random training, as it is said, random training from a set of population you are going to, or from a set of data set you are going to randomly select some data for your training purpose. Okay. 1 second. Two students are joining. Okay. So now training data, we have taken some randomly some training data, then that will be used for our prediction method. So we will apply some algorithm here. Then we will be getting some solution. So that solution you have to select the best optimal solution. So how to select the best optimal solution? By testing the data. So we will be testing our data. If we get an accurate result, so based on the result or prediction, what we have obtained here, we will be selecting the best. That solution will become your optimal solution. So here you can see this is the random training and testing model. So these are all the available cases. So from these available cases, you are going to select some larger set of data randomly. As you can see here, our training set is a larger set of data from these available cases. So randomly, we are selecting some larger training set, and we have taken some smaller set from the available cases, and that is being used for testing. And this partition we have done randomly. Okay, this partition from the available cases we have done randomly. A larger set for training purpose and a smaller set for testing purpose. So random training and testing model. Okay, so from the available cases, or in your case, say suppose in your project work, from your available data sets. Suppose if you have 1,000 number of data sets, then consider one scenario. Let us consider if you take some images, about 1,000 images, say suppose object detection. Object detection can be one project title. So object detection, there are certain objects in the real time. So let us take 1,000 number of objects, different objects, right? So for 1,000 number of different objects, that means 1,000 images you have here in this available cases. I have 1,000 number of images I have now. So from this 1,000 number of images, so around 700 images I have taken for training. About around 700 or 800 images, a larger set. It's normally 70 is to 30 or it is 80 is to 20. Sometimes we take 80 is to 20 or sometimes we take 70 is to 30. So the larger set, that is for training purpose, and the smaller set, that is for testing purpose. So 1000 out of 1000 images, I have taken 700 images for training and 300 images for testing. So randomly I am going to take the images from this total 1000 images, right? So that situation or that scenario where we randomly partition the available images, and we use that for training and testing purpose. That is random training and testing model. Okay. Now error estimate. The same thing, error estimate we have done here. So error estimate, it is also variance divided standard error. It is calculated by using the formula root over variance divided by n. Then error rate classification is a proportion, but in large samples, the error rate is equivalent to a mean. So for large samples, they are telling that error rate is equivalent to a mean. Then here for regression also, we calculate sample mean error and variance. So in this formula, MERR is nothing but mean error. Okay, mean error measure. So this has been done for the performance analysis. So error can be estimated in these ways. One is to calculate the standard error using variance and number of cases. And the second one is error rate classification, which is done using variance. So variance formula, the same with what we have done with the data samples. Instead of using the data sample, we are using the mean error here. The number of errors and mean error here. So distance calculation also can be done the same way like we have calculated using the data samples, but distance calculation here we can do using your error measures. So here it is written here, either MAD or MSE, and error I is the error distance for case I. Error I is the error distance for case I, or either this one. Okay. The same calculation what you have done for MAD, MAD and MSE, you can also do that calculation using your error measures. So error I you can consider as your actual data or actual error, and error I guess you can use here in this case for your forecasted error or predicted error. So this formula we have done, that formula you can use in terms of error also for error estimate purpose. Okay. So once again, let me go through this brief explanation about statistical modeling. Statistical modeling is nothing but our mathematical model. So every analysis for a data set can be done using mathematical representation or using some mathematical model. So in using mathematical model, we will be requiring your observed data or actual data. This is also known as your historical data. And we will be newly finding the predicted value or forecasted value. All these terms you have to remember, okay? Sometimes it will be written as forecasted, sometimes it will be written as predicted. So both terms will be similar in this chapter. And sometimes it will be written as historical data or actual data, or it will be written as observed data. So commonly there are two categories for learning this process. We have supervised learning and unsupervised learning. So supervised learning normally it is for the classes which are known, that means level classes, and whereas unsupervised learning are those classes which are unleveled, which are not known, but using the data analysis we can define or we can assign the classes to it. So these are normally used in clustering algorithms, and also unsupervised learning, they are used in association rules. Whereas supervised learning, they are used in regression and also in classification models. So idealized model, here this is one kind of method where new cases can be drawn randomly from a population sample. Population sample in the sense this is your large collection. Okay, so large collection, you have all the big samples are there. So from these samples you already have some old sample. All sample is nothing but our observed data. So this is our observed data, and new sample is our forecasted or new data, that is predicted data. How do we get this predicted data? By performing random sampling with replacement. So that is explained here. So suppose if you consider this as your population, 1, 2, 3, 4, 5, 6, 7, 8, 9, this is your population, and our initial data, which is our observed data, let us consider 1, 2, 3. Only 1, 2, 3 is there in our old sample. Now, what we have done is randomly we will generate some sample values. So randomly I have generated 2, 5 and 7 from the population sample. So our randomly generated sample can have same values with the old sample also, or it will have two different values, because we are randomly choosing from the population, right? So this process is known as random sampling. Now coming to next part, classical statistical comparison and evaluation. So comparison and evaluation, right? So we are going to do some comparison and evaluation. So for comparison, what do? We do significance testing, or it is also known as hypothesis testing. Okay, so hypothesis testing is how we test based on some observed data. Okay, based on some observed or based on some historical data, then we generate some predicted data, and we do some testing, we do some comparison in it. Okay, already we have observed data, we are going to generate some predicted data. So that two data we have now, we can do some comparison between the two data, right? So that kind of testing is known as hypothesis testing. So what are the measures we require in hypothesis testing? So average value is one method, this is one measure, mean or average, square error, difference from the mean, variance, etc. So all these are some measures which we can use to evaluate, and also this can be used for our comparison purpose. So the comparison factor is here. We are going to find the standard error for mean sample A, difference sample B, and the formula is given here. So finally, this mean difference we are going to find and compare with a significance value. So as I told you already, significance value is typically the value is 2. Sometimes it value ranges. Sometimes we use 0.5, sometimes we use 1, but normally the typical value is 2. Okay, so for most of the comparisons, we are going to use significance value as 2. But in the question, if they mention that if the significance value is given 0.5 or 0.9 or 0.7, then you can take that value for the comparison purpose. But for a efficient testing, the value is 2. Now, population variance, sample variance, I already told you the difference. Population variance is for the whole collection. For example, so for this population, if you want to find the variance, then you have to use this left side formula. Okay, this formula. And for sample variance are those nothing but say all sample, new sample, you are going to generate some samples right here. So for those kind of samples, you have to use this formula. Okay. Now, example. So example we have discussed earlier. So once again you see we have number of cases or number of transactions here, and in sample A it's nothing but our product quality, and sample B it is nothing but our product reliability. So we have two samples here with along with 10 number of cases. Okay, for 10 number for each respondent we have one value. Quality product we are asking to one respondent how much quality rating do you want to give. Suppose I want to give 3 out of 5. Example. So I'm just telling you one example. Okay. So that 3. So how much product reliability, how much value you are going to give out of 5? I'm giving 1. Example. Same respondent 2 to another person. So that I'm asking for a particular product, what is this product quality, how much do you want to give as a rating from 0 to 5. So that person 2, he wants to give 3 out of 5. And for product reliability, he wants to give 1 out of 5. Like this. Okay, this is a scenario. So directly I'm giving you the table here, but sometimes you'll give the scenario and where you have to construct the table also. That cases can be happened. So now number of cases, respondent, product quality, sample A, product reliability, sample B. So it means here for this particular example, there are 10 number of cases. So each cases have certain values. So that are samples. So case 2, 3 and 1, case 3, 3 and 1, like this it goes on until we have this the number of cases. So now sample A has 10 cases, sample B has 10 cases. So we can easily find out the mean from these sample values. So for A you can find out the mean, for B you can find out the mean. After finding the mean, what you have to do, you have to do your calculation for variance. You can do calculation for variance. So variance is calculated here. Then standard deviation or standard error. So standard deviation or standard error. So it's nothing but square root of this variance value.
Excuse me, ma'am.
Yes.
Ma'am, at variance A, there is a root under 0.177 or just 0.177? Because variance is, I think a standard deviation is root under variance A, ma'am. Yes.
Hmm.
And we calculate variance delta square, AS square. That is only
So it
variance.
is given here now. What is the value? It is standard square, standard error. Sigma square is nothing but your standard deviation. Standard deviation square is equal to this value, right?
Yes.
So variance will be root over this value, no? This is variance. Sigma is population variance, sigma square. So standard deviation will be root over this value.
Yes, ma'am. But at in their variance A is written root under, ma'am. That,
This one.
yes, ma'am. You take root
Okay,
under.
that you do the calculation. I'm just writing the values here. The calculation part I have not shown here. Okay, calculation part I have not shown here. This standard error mean difference. The formula is given here. You check the values. Did you get the values correctly or not? The calculation I have not shown here. So normally variance is nothing but sigma square. So variance is given by this formula.
Okay, ma'am.
Okay.
Yes.
So you do the calculation by yourself. That's why I am giving you the assignment also, so that you can check if you get the answers in the right way or not. So you do that. All of you must do the calculations by yourself. Either it is variance calculation or standard deviation calculation or whatever the calculation given here. Formulas are all, even if you don't see the formula here also you can check it from internet what is the formula for variance. The normal mathematical in statistics, we have already studied about this variance calculation, standard mean calculation, median calculation, mode calculation. So check it from that formula also, and check the calculation. But the calculation should be a comparison with significance. So significance is tested by this formula. Okay, the first formula is this one, standard error, and finally mean difference you have to calculate. Okay. Now moving on. Where is it? So this is another scenario for the calculation of sample mean and variance. Okay. So sample A with 5 cases having these values and sample B with 5 cases with these values respectively. So you have to find the sample variance and standard error, and also you have to place a significance. Our significance value is 2. For an hypothesis testing, significance value is 2. So you check it for this formula, this one also. This particular question I think I have included in the assignment question. So check it, calculate it, and you submit the. Let me check the answers. And predicting true or false. So normally this is classification. Either we separate all truths or all false or zeros and ones, whatever. So that predicting whether it is true or false, or separating a particular problem into two classes, that is classification, right? So sometimes 2 or more classes we can have. That also we will study in your chapter number 5. The error rate calculation, that is nothing but the percent of classifications that are incorrect, which is to be calculated in percentage. So that is given with this formula. And forecasting regression, normally I told you it predicts a number. The numbers can be real number or ordered numbers, but not categories and levels, not the names of the classes. Then regression line or line of best fit means that has a minimum distance with the data points. Okay, we have already explained regarding this, that has minimum distance with the data points. If you consider this as the regression line, the red colors and yellow, these are the data points. You have to find the distance either by using your Euclidean distance or absolute distance. And if you have the minimum distance, that becomes which means the data points which touches on the regression line. So that forms the line of best fit. So distance measure, two ways are there, mean square error and mean absolute distance. And mean square error, the formula is given here. So yi is the actual value, yi yes is the predicted value. Okay. So that example is here. We have two observed value and predicted value, and we have number of cases half yearly sales. So the sales of an half yearly is being recorded here from January to June along with their observed values. And in lakhs, suppose 125 lakhs rupees were sold in January month, but actually our predicted value was 128, but this is the observed value. So our predicted value was 117 in February, but the actual value was 132. 105 predicted value, actual value is 115. So like this, you will be given some data, and from this data you have to find out mean square error and mean absolute distance. And now coming to the next example, computing error measures and moving average. Error measures where you have to find out, as I told you, it is written in the question, computing error measures you have to find in this format. So where you have to find the error, absolute error, error square, error percentage. So these are all error measures. Okay. So I told you already about how to find moving average, right? So if it is a 3 moving average, you have to move 3 data points, find the mean, then write from the fourth week your value. Okay. Because if you find mean for this 3, you have to write the predicted value here. Then remaining this again next consecutive 3, the value mean here. Next this 3, the value mean here. Next this 3, the value here. Next this 3, the value here. Like this we calculated 3 moving average. Now this moving average which we have calculated becomes the predicted value. Since we don't have any predicted value here, we will skip calculating the error for this first 3 weeks. We will calculate error from the fourth week. So since we have the observed value and predicted value from the fourth week, we can calculate the error. The error is calculated using the formula actual minus forecast. So here it's calculated just by getting the difference between these two values. So absolute error we have calculated here, error square calculated here, then error percentage. So how to find the percentage? So 4 is our error which we have obtained, and from this 4 divided by our actual these values, 4 divided by 45. So some value we get that into 100%, that is 8.89, nothing but our percentage error we have to find. So individual percentage errors are calculated here, and finally you take the mean for this individual percentage error. That will give you mean absolute percentage error, which is 8.60. So this computing errors and this one is very important, okay? And for casting example, for this particular example, we don't need to find out the moving average because directly they are given along with the predicted values. Forecast is nothing but our predicted values. Demand is nothing but our observed values. So all observed values and predicted values are given here. So directly we can start finding the error, error absolute, error square and error percentage. And one additional measure which we have added here is the tracking signal. So tracking signal is one additional measure which we have added here. So this is given by this formula. Actual summation, actual minus forecast divided by mean absolute distance. So we have already calculated actual minus forecast value. So for all these actual minus forecast value, this error values you do a summation. Then after doing this summation divided by MAD value, which is calculated here. MAD means absolute distance, MAD. So that value will give you your tracking signal. Now, random training and testing randomly from the available cases, a larger set you are going to take for the training purpose, and the smaller set you will be taking for your testing purpose. So these are some error estimates. Error, standard error you can calculate, variance you can calculate. So comparing results, the same thing, hypothesis testing. In hypothesis testing also we have done comparison with the significance. So as I told you here, so the same comparison what we have done using the actual and forecasted, we can also do here with the error measures, only for the errors, okay, error measures. So individually for the error measures also we can do some significance comparison. The same thing, this A will be your mean error for sample A. B will be your error for sample B, all the error values for sample B. So here, instead of finding mean of A and mean of B, we are finding mean error of A and mean error of B. Okay. This is just for your understanding purpose that the same calculation can be done for the error measures also. But the calculation here is important. Okay. All these calculations which we have done here, at least 3-4 calculations that are important for your exam. So that is statistical evaluation. Okay. So now after this we will have uh, data preparation. We will have data preparation. This is your new topic. For data preparation. Data preparation is normally done to define the data quality. Data quality means what? It is in terms of accuracy, in terms of completeness, in terms of consistency, and in terms of timeliness, believability, interpretability. Okay. So let me share the screen for data preparation. Okay. Preparing the data or data preparation is normally done to define data quality. Okay, data quality. So these are the features of data quality: accuracy, completeness, consistency, interpretability. All these are data quality. So to organize data, the initial stage is to organize data into a standard form. So I told you in our first class also, every row data will be converted into a standard form. Standard form is nothing but your spreadsheet form, or it is the tabular representation of the data. Now, after constructing or organizing your raw data into the tabular representation, we have to prepare features that lead to best predictive performance. Okay, so there will be some features uh, which we can use for the prediction purpose. So that features we are going to prepare. First one, to organize our data into the tabular representation format. And secondly, we are going to prepare the features that can lead to best predictive performance. So our spreadsheet data format is nothing but this one. So I have already shown you this in our last class also. So we have features here, we have number of cases here, so the value. So for case 1, feature 1 value. Case 1, feature 2 value. Case 1, feature 3 value, and so on. Okay. So there are rows CI is the ith case, and column entries are values of measurements. I told you this V11 is nothing but the values of measurements. So this is just an explanation. So how the values, so what is V11, what is V1K, what is VI11, so which I have just explained now. It's nothing but the value of measurement for what? For case 1 and feature 1, that value. For case 1 and feature 2, that value. Okay, that has been explained here. Next, standard measurements. For standard measurements, we have two types of measurements. Either it is measured in true or false format, or it is measured in ordered variables format. So let us see the first one, true or false format. So here in true, it can be encoded as 1, and for false, we can encode with 0. Okay, so these values are encoded as 1 for true and 0 for false. For example, feature J is assigned 1 if true, otherwise 0. Okay, so true or false variables is nothing but we can make a Boolean representation using zeros and ones. Ones will be represented with true for those which are true, and zeros will be represented for those which are false. This is a similar concept with your ISR Boolean representation, Boolean retrieval method. In Boolean retrieval, what do? We just put 1 for the terms present in the document, right? And for the terms not present in the document, we put 0. Likewise, what we have done is for those two variables, we have encoded with 1, and for false variables, we have encoded with 0. Now, in ordered variables, as I told, ordered it will be two values, okay, or else it will have some meaning. So these are numerical measurements where the order is important. X greater than Y has some meaning. Okay, whether it has some meaning or whether it will have two variables in it. That is ordered variables. Now, just examples of difficulties in mapping data into standard format. So this is just one issue which we faced while mapping the data, raw data into standard format. Okay, raw data, as I told you, everything should be converted into standard format. So while converting into standard format or while mapping the data into standard format, we find some difficulties. So that difficulties they are written here. The free text in the sense like it can be any form of text. Can be like it can contain some numeric data, it can contain some this one no alphanumeric data, it can contain some images, it can contain some videos. So like it can be any form of data, so free text. So any form of data, but while mapping it will be difficult since if it is like if your data is similar the kind of data, you can easily map your data. If it is all numeric, you can easily map. If it is all textual, you can easily map. If it is all images, you can easily map. Sometimes, if it is a mixture of all these data, then automatically you will find difficulty in mapping your raw data into the standard format. And replicated fields are those repeated data, multiple times will be recorded in your data. So it will occupy more spaces also, and this will lead to another this can lead to another your data reduction steps. This is again time consuming, right? So which means here replicated fields multiple instances of the same feature recorded in different data fields. Okay, the same features. So repeated data will be there in your standard format, right? So the one disadvantage for having recorded repeated data is your data storage. Your storage will occupy more, and in normalization also it will take time. So it is time consuming, and storage issues you will face in replicated data if it is recorded. So what are the major tasks in data processing? So these are important: data cleaning, data transformation, and data reduction. So this will be important parts of data preparation. Okay, so data cleaning. So before we prepare the data, that means before we map the data into your standard format, we need to clean the data. So data cleaning, I already told you in chapter number 1, it is nothing but removing your inconsistent or noisy data or repeated data we can say. Okay, so real world data tend to be incomplete, noisy, and inconsistent. So data cleaning, this will attempt to fill in missing values, smooth out noise while identifying outliers and correct inconsistencies in the data. So data cleaning will clean all those inconsistent data, then it will fill missing values. So filling missing values means what? Sometimes let us consider in a banking environment, so all employees data collection is being done. Okay, so employee 1, you will write the name, you will write the address as feature, and thirdly you will write the income, suppose. So employee 1 income 15,000, employee 2 income around say 20,000, employee 3 income around 30,000, employee 4 income it is missing. We don't find any value. Then employee 5 income, it will write. Employee 6 income, it will write. So only employee out of, suppose let us take employee 10. We have employee 10 employees, and all their income values are written in the format. Only income number 4, which means employee number 4's income is missing. So in that case, what will we do? If it is missing, then the data which we have calculated won't be accurate, right? So if it is missing, what you are going to do? So we are going to fill the missing value using some techniques. Using some techniques that we will study. Missing values. So ignore the tuple. Ignore the tuple. So that example which I have given you, employee number 4. Either we can just remove that employee number 4. Totally, if you take out employee number 4, then there won't be missing value. But this data which we have deleted could be useful in our data mining process, right? So ignoring the tuple is one way to solve missing value, but we may remove some useful data from our database, right? So this is one method which can solve missing value, but at the same time it has some disadvantage also. The disadvantage is nothing but we could have deleted some useful data, right? So our next method is fill in the missing value manually. So ignoring the tuple is what I have explained now. This is usually done when the class label is missing. As I told you, when the class label, when some attribute feature or when some class label is missing, then we will just remove that particular data which is missing. But by ignoring the tuple, we do not make use of the remaining attributes values in the tuple. Such data could be useful to the task at hand. So this is what I have told you now. Okay. So like uh, employee number 4, say employee 1, name, address, income. Employee 2, name, address, income. Employee 3, name, address, income. So all these values are given, and except in employee number 4, the income is missing. But if we delete whole employee number 4, employee name also will be deleted, which is one attribute name. Then employee address also will be deleted, which is one attribute in the table, and employee income, which is already missing, it will be deleted, right? So our missing value problem is solved, but on the other hand, we might lose some information about the banking or about the employees, right? So now fill in the missing values manually. Here also, what we have to do, if the employee number 4 salary is missing, what we can do is we can just look up in the database and one by one, then we can fill it manually. So this will solve the missing value problem, but it is a very time consuming process, right? Because when we have larger set of data, like checking up and filling up manually automatically takes time, right? So it is a time consuming process. We solve missing value problem, but time consuming process. Now, use a global constant to fill in the missing value. Use a global constant to fill in the missing value. That means when that particular attribute field is missing, so that missing value, we can replace it by some label like unknown or not applicable or -1. So these things you might have already come across some in application forms and all, right? While filling up, you have written not applicable, unknown, like that. So our missing value problem is solved in this case. But when we actually need the data, it might be sometimes it causes confusion to the person who is actually needing the data, right? So next one, use the measure of central tendency for the attribute, either mean or median to fill the missing value. So this is also one method. It is quite useful because here we are going to fill the missing value and also we are going to solve the problem. How? By using a central tendency of the attribute. By using a central tendency means what? Normally it is mean or median. So for a yes, yes. Okay, I think the time is already over. So let me just finish this part and the rest we will do tomorrow. Only this part let me finish. Use the measure of central tendency. So central tendency means what? We can use either mean or median. When to use mean, when to use median is the only factor. So mean we will use only for symmetric data where you can equally distribute the data. In that case, you are going to use uh, mean, otherwise you can use median. So for example, 1, 2, 3, 4, 5, 6. So we can equally distribute this data. So this data are known as symmetric data. So for such kind of symmetric data distribution, we will be using mean. And sometimes we have 7 employees, 11 employees, for those which we cannot equally distribute. For those that we will be finding the median. So see here the mean for symmetric data, the mean can be used while skewed data distribution should employ median. Skewed data distribution is asymmetric data distribution which you cannot equally distribute it. For that data you are going to use the median, and normally for asymmetric distribution you can use mean. So let us see this example. So for I have around 6 customers along with their respective incomes and one class which whether they can assign loan or whether they can apply loan or not. Yes, denotes for applying the loan, positive, and no means they cannot apply loan. Okay. So now since one value is missing here, so we have to solve this problem, right? So for this, he has already applied, but it is the value for income is missing. Since the value for income is missing, we cannot decide, the bank cannot decide whether this customer number 3 can apply for loan or not. So what we have to do, we use a measure of central tendency. So for the attribute, right? Attribute is nothing but this income is the attribute. Applied loan is your class level, we can say sometimes it can even act as an attribute, but for this particular example, this is your class level, class 1 or class 2, class yes or class no, class true or class false, like this, okay? So mean, you have to apply a measure of central tendency for the attribute, which means we will be using mean in this case. How to find mean? So we have 15,000, 20,000. So for these incomes, you take a mean of these incomes. So then get the value. So once you find the means here, we will get the value here. So that value we will fill up in this missing part, and after taking the missing value which is filled up here, we can decide whether we can apply loan or not, right? So normally as you see here 16,000 he cannot apply loan, but 17,000 he can apply loan, right? So if it is lesser than equal to or lesser than 16,000, he cannot apply loan. If it is equal to 17 or greater than 17,000, he can apply loan. So from this itself, we can just take out one decision rule. So from that decision rule, we can easily assign. Right. So here, 1 second, I'll show you. Comparison 100 plus 3,000 plus 15,000 plus 20,000 plus 2,000. So around when you take in around it, I get around 17,200. Okay. So around 17,000 I got approximately. So 17,000 here itself you find it is not applicable for applying the loan. And for 18,000, 20,000 it can apply, or 17,000 it can apply loan, right? So this person can apply loan. Like this, we will fill up the missing value with a center of or with a measure of central tendency for the given attribute, right? So you take a mean and you just analyze the values here. 16,000 no, 15,000 no. That means equal to 16 or lesser than 16 we can apply for loan. But here around you get 17,000 yes, 18,000 yes, and 20,000 yes, which means equal to 17,000 or greater than 17,000 we can apply loan. So like this, using a central tendency, we fill the missing values. Okay, so let us continue tomorrow. We have other examples also. So these examples we will continue not tomorrow, on Thursday in our next class. So let me take our roll call for today.